So in this example, we are first introduced to the division algorithm. And I think the easiest way to introduce the division algorithm is through old school long division. So for example, suppose we had something like 256 divided by 17. And in grammar school, we would do it like this. We would do 17. Then we would have this box. Remember that? And then we would put in 256. Then, of course, what we would do is we would divide in parts. We would take 17 goes into 25. 17 goes into 25 once. We would then do 1 times 17. That's 17. And here's an important part. We would then subtract. 25 minus 17, that's 8. And then we would bring down our next digit here of 6. Then we would repeat the process. 17 goes into 86. 5 times 17, it's 85. And we would subtract. 86 minus 85 gave us 1 left over. The 256 here, this value here, that's known as the dividend. This value here, 17, is the divisor. This value up here, 15, is the quotient. And of course, this value down here, the leftover, is the remainder. And of course, the way to check our work to make sure it was okay is we would take the quotient, multiply it to the divisor, add the remainder, and it should come out to be the dividend. So 256 should be equal to 15 times 17 plus 1. And in essence, that's our division algorithm. Our division algorithm says A is equal to Q times B plus R. And Q and R, Q is our quotient, and R is our remainder. Now, a couple of things to keep in mind is our remainder always has to be less than the divisor. If it wasn't, then the division would continue. As you can see here, we had a remainder of 86, but we continue with the division. So here, it's less than our divisor here. So the remainder can be greater than or equal to 0. And if you remember from old school long division, if we had a remainder of 0, we would say that the divisor goes into the dividend evenly. Remember that? But it's got to be less than the divisor. Another thing to keep in mind is that A, Q, and B, and R, all these variables have to be integers. And you can see that they are. They're all integers. Now we're going to use our calculator to speed up our process. You can use your calculator to its fullest capability, but I like to do it old school because it lends some clarity as far as what's going on. And maybe you can use it to help you as you do some of this division. So of course this example says determine the quotient and remainder for the following divisions, and we have 122 divided by 14. So I'm going to say 122 divided by 14. And we'll do it the old school way. That means 14, we have our box, and 122. So on our calculator, I'm just going to type in 122 divided by 14. And we have a decimal output. So 14 does not go into 122 evenly. We have this decimal output. So we round our decimal down to the nearest integer, and that would be 8. So then I put here 8. And then, of course, 8 times 14. That's 112. So we have 112. And here's the important part. We subtract. 122 minus 112. That's 10. So writing it in terms of the division algorithm, we have 122. That's equal to 8 times 14 plus 10. So our quotient is 8, and our remainder is 10. Let's try B. 2,374 divided by 113. We have 113 in our box. 2,374. 2,374 divided by 113. Again, we're looking for an integer. This will be 21. We round this decimal down to the nearest integer. That's 21. 21 times 113. That's 2,373. Then we subtract, and we have a remainder of 1. So writing this in terms of the division algorithm, this will be 2,374. That's equal to 21 times 113 plus 1. So our quotient is 21, and our remainder is 1. And then for C, I'll put it over here. 6 divided by 7. So then we would have 7 as far as our long division goes into 6. 6 divided by 7. So again, we have this decimal. We want integers, so we take this decimal and we round it down to the nearest integer, and the nearest integer would be 0. So our quotient up here winds up being 0. 0 times 7, that's 0. We subtract, we have a remainder of 6. Writing it in terms of the division algorithm, 6 is equal to 0 times 7 plus 6. Our quotient is 0, and our remainder is 6. And there we go.